Change the amplitude.
Okay. To all of you physics nerds again who are gone, this, I guess we can call this section Fun with PHET. This is PHET simulations right here. You can go through these on your own if you want. But this is really cool thing to go through. This is an example of just showing how a wave, the periodic nature of a wave, when you drop a drop in there, you get a pattern. If I increase the frequency, I should increase the number of drops per second. And notice the spacing between the waves decreases because the velocity of the wave in that medium is constant. And so if you have a higher frequency, then you're going to have a lower wavelength if the velocity. Now when you go from one medium to another, of course, what doesn't change? The frequency doesn't change. But in this case, we're in the same medium, so the velocity stays the same. And by increasing the frequency, we decrease the wavelength. And I can rotate. Oh, this is pretty neat. That's pretty neat.
Whoa.
How neat is
That makes
that?
more sense.
Yeah.
Now, what they're showing here is the wave, the amplitude decreases. Okay? So I can increase the wave, the amplitude, and what that would probably do is just have a bigger drop of water. Yes.
Ooh.
And when I have a bigger drop of water, my wave has more energy when it hits. Let's rotate the view this time now. And basically you can't really tell the amplitude from that picture. What we have there.
Do it at 45 degrees.
I don't think you can.
Ah.
On either side or nothing. Alright, so that's basically, now if I do the same thing with sound, this is basically a sound wave.
What?
This is basically showing the compression. This is, instead of showing the wave as a transverse wave, this shows the wave as a compressional wave, and that's what a sound wave really is. It compresses those molecules. We get compression. The part in the middle is rarefaction, where the air is thin, like the rarefied atmosphere, compression, rarefaction. Or you could show it like this, and so you're creating sound waves, and with light, you have the same situation right there, and I can have this light hitting a screen, and notice it lights the screen up perfectly all evenly. Okay? Here's the screen, and all those waves hit it. But that's because I have just one source of light, and I have no barrier. So let's put in front of that with water now. Let's rotate that. And let's put a couple barriers in between, and let's slide this over.
Whoa.
And notice you see the diffraction pattern, don't you? Okay, you see it right there. You can see, let's change that slit width a little bit. And that's going to affect our pattern a little bit.
A lot.
A lot. You can't see squat.
What is going on? Okay.
Yeah, that's probably not showing very well on the camera.
No, you can see it.
Yeah.
Well, you can see kind of the diffraction pattern, but you guys at home, you can play with this to your heart's content. Just go to just Google PHET physics, and they have all kinds of, for any of the sciences, they have calculus stuff too, math stuff, and it's really quite pleasant.
Slit.
So let's do the two slits here, and let's
Oh, cool.
change the width of the slits.
Okay, well, it's all dark now on the screen.
Yeah, this is not doing the squat. Alright.
Unless you change the wave.
Alright, so, now you can see the screen right there. And what you're seeing on the graph is the intensity on the graph. Let's see if I can change it just a little bit here. Alright, well, you notice you're seeing a big bright spot in the middle. You're not seeing, okay, you're seeing a bright spot, kind of a dark spot, and up here it's not as bright, but you're getting some more constructive interference.
Change the wavelength.
Let's change the amplitude of the wave. Let's change the wavelength.
What?
Red light is the lowest, is the highest wavelength, but it's the lowest energy. Because the energy of a wave depends on its frequency. And since all waves travel at the same speed, V equals F lambda, but all these light waves travel at the speed of light equals F times lambda. And so the higher the frequency, the lower the wavelength. And red light has the highest wavelength and the lowest frequency. And this would be red, and then you can't see it would be infrared, then violet light, and ultraviolet light. And so violet light has the highest frequency, it has the highest energy. And so ultraviolet light is what will give you cancer, will burn you, isn't it? Alright? So now you notice the screen right there. The screen is still, you can't really see probably very well. But you can see here the intensity.
Hers, try
Basic-
yellow light.
Let me increase the amplitude, see if that makes a difference.
Well, you can't really see the purple on the screen.
You can see the screen. Basically, this shows the intensity. Oh, there you go.
You can see it.
You're seeing those dark
Whoa.
lines. Now, I actually have a laser that we can set up, and we can actually create this ourselves with the laser
Can we do that?
and so on.
This just has
You can
several
see the
lasers.
bright spot, dark spots, and notice this dark spot corresponds with low intensity, high intensity, low intensity, high intensity as you go along. You can try the color, maybe the yellow light will be easier to see. Yeah, that's probably easier to see on the camera.
Yeah.
With this one, we pretty much see a bright spot, bright spot. Now, these parts right here are called fringes. This middle fringe is called your zeroth fringe.
Zero.
Okay? And this is your zeroth bright
There's
fringe.
dark spots along the bed here.
And this is your dark fringe, zero fringe, and this is your first, this would be, and the fringe number, they use the little letter M for fringe.
That
M.
makes
M.
sense. I'm
And-
fringe.
M for the, yeah, it doesn't make any sense. So, but I'm just saying how they do it. I didn't say I like it, but that's what they do.
Whenever we're watching Fox.
Alright, so let's change this. See if that makes a difference.
Like that show.
Fringe.
Well, it didn't
Whoa.
like that.
Missed it.
So I need to let a little more light through there.
One or two lights.
Oh, can I do two lights? Oh yeah, let's try two lights.
Ooh.
Oh, indeed. Alright. So I have two, whoa.
Whoa.
I have two lights. So let's lower that amplitude a little bit, see if that makes a difference in our intensity.
What is going on with the graph? What the?
Indeed. Alright. So now we're getting a,
Wow.
well, you're kind of getting a difference right there.
Can you open the slits a little bit more?
Can you do a rotate view? No, you can't do it here. Alright.
Nothing to rotate.
Okay.
Ooh.
So there's fun with wave interference, and pause it now.